Okay. Welcome to class again. Before we start today, does anybody have any questions for me? Questions about assignments? Questions about last class's material? Anything? Yeah? Do we get anything out of what? Yes, you get bonus marks. If you did the bonus questions and did them right, then you should get bonus marks. Now, what you'll find in See You Learn is that the assignment will be marked out of 22, but that's actually only out of 20 because there's 10 questions plus one bonus question. So if your mark is higher than 20, that's because you have bonus marks. See You Learn just doesn't let you give more than 100% on an assignment, so we have to do it that way. But when your grade is tabulated at the end of the year, that'll be counted as, you know, if it's 22 out of 22, it's 110%. Any other questions? Good. So you all understand for loops, while loops, if statements, all the stuff we did last class. Good. Then what we'll do today is try and piece everything together. So I know that the last few classes, or the first few classes, is basically trying to get all the major pieces of a programming language taught to you. In this course, and using Python in particular, that happens a lot faster than in other classes. I've taught courses before where, for example, I've used textbooks where for loops showed up on page 267 of the textbook for the first time. We did those in the third class, I think. So you can get up and running really quickly. And now that we've gotten all this stuff, we've sort of seen how to use the individual parts, let's try and actually make something. So for the next couple of classes, we're going to try and make a few text-based games that illustrate all of this stuff, and also at the same time, they'll illustrate how you start from scratch and make a program that's not completely trivial. So that's not just one function at a time, but actually does some stuff. Now this making programs and designing programs, there's a whole field of software engineering devoted to the right way to do this. There's lots of theories about how this should work for small programs, for medium-sized programs, and for large programs, where small, medium, and large really have different meanings to different people. So they could be dozens of lines of code, or thousands of lines of code, or hundreds of thousands of lines of code, or even millions of lines of code. But for our purposes, we're going to be writing fairly small programs, the kind of thing that a single developer can do in, well, certainly in the course of a week, because that's usually what you have for your assignments. Maybe some of the assignments I'll give you some advance warning and you'll have 2 weeks to sort of prepare for them, but they're not huge. And for that, we'll sort of do a mixture of bottom-up and top-down, with a strategy of trying to make a program that at all times runs, compiles, does something. It just may not do at all times all of the things you want it to do. So always working with a program that works, and then just continually adding features to it until it works better. So the first thing I would like to do is implement. It's sort of a child's game almost, and it's a guessing game. And here's how we play the game. The computer picks an integer between 1 and 1,000. And you're supposed to guess that integer. You have 10 tries, and every time you guess, the computer either tells you you're correct, no, your guess is too high, or no, your guess is too low, and you get to guess again, and you get to do this 10 times. So that's what we want to implement. That's the specification for our program. It's just a simple guessing game, and you play it once. You don't keep playing it over and over because it's actually not that exciting once you learn how to do it. But that's the plan. So that's our specification. So let's fire this up, starting with an empty program. We'll put our usual line at the top. In case we happen to do any division, we want it to be the right kind of division. And now we'd like to start implementing this program. So what's the first thing we could do? Yep.
Import random.
Import random. So why random? Because the computer is supposed to pick a number between 1 and 1,000, and then you're supposed to guess it. And there's some chance that somebody might like to play this game more than once. So if the computer just picks the same number every time, it becomes pretty boring after the first time you play. So we'd like some way for the computer to pick a different number every time. And if you've worked at all with these kinds of things before, you'll realize that that's the kind of job that's done by a random number generator. And then you'll say, well, in Python, how do I get random numbers? So you Google Python random, and you'll find a section of the Python manual, the first thing that pops up, on generating pseudo-random numbers. And there's a whole bunch of different things. So there's a module called random, and a bunch of different functions in here. And the one that looks interesting for us under the subsection of functions for integers is rand range. If you give it one argument, it returns a randomly selected element from the range going from 0 up to stop -1. So if you read this documentation, this is like choosing from the range start to stop by step, which if you just specify stop, it's like taking a range from 0 up to stop -1. So the first thing we'd like to do is have our computer pick an integer, a random integer between 1 and 1,000. So that's what we'll use. So from this random module, we want to import this function called randRange. And we'll call this thing that the computer picks, we'll call it x. And we want to pick a number between 1 and 1,000 inclusive. Does that do it for us? The function is called randRange. The module is called random. So from the random module, we want to import this function called randRange. So will that do it for us? No. What's wrong with this? Yeah. So this will not give us, we'll never pick the number 1,000. It'll only pick up to 999. Will that do it for us? No. Why not? Because this might pick 0, and that's sort of outside the rules. So we'll pick a number between 0 and 999, and then we'll add 1 to it. Okay. And we might as well print something. Okay, so at all times we want to have a working program, so let's see if we have a working program. Good. We have a working program. It says I'm thinking of a number in the set 1, 2, 3 up to 1,000, and it picks that number from the set, but that's the end of our program now. Okay, what next? So think of the tasks that we need to perform to complete our program. What's another sort of subtask? Or what's the next step that our program should do? Yeah? You'll need if statements to say if your number is right or wrong, if your guess is right or wrong. Before you can do that, what do you need to do? Yeah? So we need to ask the user what their guess is. So how do we do that? Yeah? Raw input. So let's see. So let's try and say raw input. Try and guess it. And whatever that is, we'll call that the guess. Test that program. I'm thinking of a number in the set between 1 and 1,000. Try and guess it. Well, I will guess 1. And the program ends. Okay, so far so good. Now what? Yeah. We want an if statement that will test to see if that number is correct or too high or too low. Okay, so what would that look like? We may have to do some backtracking here, but let's see what that would look like. Yep. So x is the number that the computer picked. So there's somehow 3 cases here, right? The guess could be less than x, it could be bigger than x, or it could be equal to x. So one of the cases is if you guess too low, then you'll write something like print nope. Your guess is too low. Otherwise, if your guess is too high, we can print nope. Your guess is too high. And otherwise, we can print correct. You win. And remember, one rule of games is to make them fun, put in a lot of exclamation marks. In fact, anytime you're trying to make a point, always use a lot of exclamation marks. It makes people take you seriously and really remember your point. Caps lock is really good too. So let's do that. Let's shout it. I mean, it's perfect. Okay, is this going to work?
No.
Let's try it and find out. Okay, I'm going to guess 10. It says, nope, my guess is too high. All right, so the end of the game is over. So that's not quite what we wanted. We didn't just want to give one guess. That wouldn't be so interesting. I'm going to try and guess 1. It says, nope, my guess is too high. Any idea what's going on? Yeah.
You need to put a while loop, so it'll keep running until you get.
We will eventually need to get a while loop to keep repeatedly asking the question, but there's a bigger problem here. It's reported that my guess of 1 is too high. That's not possible. Yep.
Either the programmer started and picked a new number, or you need to let it pick all the numbers. So
No, rand range will give an integer. In fact, if we want to debug, we can see print bug x equals x. So the number that it picked is 625. So let's guess 1. Nope, too high. Yep.
It's because raw input is taking a string and needed to meet conditions.
Yeah. So let's go in the Python interpreter and try and figure out what's happening. So I'm doing something like this. Guess equals raw input. So that's something we can just do right in the interpreter. So I will guess 1. And let's look at guess now. It says my guess is 1, but look closely at this and get used to looking closely at these kinds of things. This 1 is in quotes here, meaning that it's a string. So that's not good because we picked an integer x. We picked an integer x. This time it's 457. And so now, in this line where we compare guess to x, well, we're comparing this thing on the left, guess, which is a string, to x, which is an integer. And that's, that doesn't make sense. Yep?
So why would that give an error if you're comparing two completely different?
Oh, because it has some idea of what it means to compare a string to an integer, but it's not what we want. It's not by converting the string to an integer, it's doing something else. I don't know what exactly, but it's doing something. Yeah?
Is it trying to guess compare the Unicode around or something?
I don't know what it's doing, but it doesn't matter because it's not the right thing, so we need to fix it. So the real problem is, and this is a problem that comes up all the time, is that stuff that comes from users or stuff that comes from external sources, networks and other places, usually is just a bunch of strings. If it's from the user, it's stuff they're typing on their keyboard. If it's coming across the network, it's some stream of data that comes across the network. But it's just a character string, typically. And we want some structured data. In this case, we want an integer. So we can do that by just saying raw input returns a string, right? So let's convert that string to an int. And let's try it now. Okay, I'm going to guess 1. Good. So now it says my guess is too low. Let's try again. I'm going to guess 900. Good. Now it says my guess is too high. Let's try again. I'm going to guess 480. And now it says I'm correct and I win. It was a little bit easy because we got to see the number from this debug statement, but looks like this code now is correct. All right, what next? Yeah. We need some kind of loop. We could do a for loop. So for loop around what? So let's hide this debug statement again. So what does the for loop go around? Yeah.
You could do it a range of 1 to 11 times.
Okay, so we could say for I in range 10, That'll give us 10 guesses. So I will take on the values 0 through 9. Maybe we can compute something from that. Or if you like, you could say, if you want to be fancy about it, you could say for I in range 10 down to, but not including 0, and counting by -1, that'll count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that'll do that. All right. And maybe we can say, be a little bit nice here. We can say try and guess it, and we can say how many guesses they have left. See if that works. Okay. It's thinking of a number between 1 and 1,000. Try and guess it. You have 10 guesses left. Now it's your time to play. 500. That was too low. 750. That was too high. 6 what? 625, 650. Let's try 625. That was too high. That's not optimal, but sure. Too low. What's the next suggestion? 575. Too low. What's the next suggestion? 600. Only 4 guesses left. Too high. You guys are lazy. Too high. 582. Still too high. 577. Too low. No, you lose. So you guys were a little bit lazy here with your calculations, because it's always possible to win this game if you guess a little more carefully than that. But some of your guesses were not optimal. So by playing through this, we see a couple of things. One is the game ends kind of abruptly. It just says, that's it. No, your guess was too low. So maybe we'd like to clean that up a little bit. So maybe if you actually never win, so maybe if you win, it's just time to quit. So we'll say, in that case, we exit. And I don't remember if the Python... Let's not do that. Let's just let it run to the end. So let's say this thing finishes, and so now this thing finishes either because, well, no, let's try and exit 0. So if we guess correctly at some point, we'll exit. And if we never guess correctly, then we'll reach the end of this thing, in which case we should print some message telling them that they lost. So oops. All right, let's try that. Okay, I want to lose just to see if this actually works. So let's say I'm going to guess 1, 1, 1, 1, 1, 1, 1, 1, 1, and it says you are a loser. Good. Now let's try and win the game. See if that branch of the code works. So our first guess should always be 500, 750, 825, 900. 910 is, I think, a better choice. Too high. Now what? 875. Too high. 850. Still too high. 830. Give a better suggestion, those who are saying no. 837, 838. Still too high. 832. Too low. Now what? So let's pause for a second. What do we know? It's bigger than 832 and it's less than 838. So it could be 33, 34, 35, 36, or 37. There's 5 choices there. And we have 2 guesses left. So 3, 4, 5. We may get lucky. That was too high. 33 or 34? The 34s have it? No. You cannot afford in this game to make suboptimal guesses. Yes. So you really want to split the domain in half all the time. So let's oops. So now we know the answer, so let's try 50, that's too low. Let's try 500, no, and let's try 510. Correct, you win. Okay. So, great, that works for us. See any other issues with this game? Yeah? Well, you're told the answer, but that was just for debugging. We can... Sure. You are a loser. My number was X. So you can be told what the truth was at the end of the game. Any other issues? Yeah.
You can pick the same number twice.
That's sort of like your problem then, yeah. But it's related to that. So imagine I'm like really excited to be playing this game. Yeah.
My code has an issue with the exit 0.
It prints a backtrace?
Yeah.
Yeah. Yeah, that happens in some environments. Exit is not maybe the best way to do it. We can try a different strategy then. So instead of exiting, there is a command called break. which exits the current loop, the innermost loop. So in this case, we're in a for loop. So if we call break, we will exit that loop and move on to the next line. Now the next line says that you're a loser, so that's not what we always want to do. You're only a loser if I made it down to 0. So, so this will work. This will do the same thing. We can just check that. What's that? Yep. So print debug examples. We'll try both branches of this. I'm going to try 2, 3, 4. And now we actually exposed the bug that I really wanted to see, but again, because I got too excited by playing this game. So that exits. I guess I was wrong about the value of I at the end of that loop. I is 1. Yeah, that's maybe the easiest thing to do. Let's return, and otherwise print this. And now, usually, you want to do this anyway. We'll put this whole thing inside a function called play game that will return, maybe in the case where you win, and just also return in the case where you lose. And then our program does one thing. It calls the function play game. Okay, so you lose, it tells you the guess, and if you win, 637, correct, you win, it leaves you that way. Okay? So, seems to work, but there is a little issue that I don't like with this thing so far, and that is that if I get really excited, because it's such an exciting game, you know, I might be trying to type in these numbers as quickly as I can, and I might type in a number like this. And then the whole game gets spoiled for me because this thing crashes. Because I typed in something that was not an integer. Yep. Yeah, so I would like to, and I want you, anytime you're making applications, to be able to handle invalid input from the user like this. So this doesn't have to be true of every function that you write, but things that interface with users, things that read strings from users, and things that you know, work with the keyboard or mice or whatever, they shouldn't crash because the user pressed the wrong key or they clicked the right mouse button and they weren't supposed to do that. They should somehow recover nicely from this. And one of the hard things is when you ask the user for an input string and you expect it to be of a certain form, like being an integer in this case. So in this case, we take their input string, and that comes from raw input here, and we try and convert it to an int. And sometimes that fails because the string doesn't look like an integer. So there's a few things we can do about that. The hard way to deal with that is to first look at the string and make sure that it really looks like an integer. So then we have to decide what it means to look like an integer. Well, that means the characters in the string should only be 0, 1, 2, 3, up to 9. The string shouldn't be the empty string. It shouldn't have length 0. So there's a lot of things to check there. But there's actually an easier way to do it. And that's just to try and convert the string to an integer. And if that fails, ask them for another input. Tell them it was no good. So let's look carefully at the message we got here. It says that when we tried to convert that thing to an integer, we got what's called a value error. And there's all kinds of these errors that pop up in Python. You've probably seen them when programming. These are so-called runtime errors. So this is a program that compiles and runs, but then at runtime something goes wrong. And this is one of the things that can go wrong, a value error, meaning that the argument to int somehow didn't have the right format. So there's a whole mechanism in Python and in many other modern languages called exception handling for dealing with these errors so they don't crash your program. And it looks like this. So it's called the try, except, or try, catch mechanism. So whenever you have a block of code like this that might fail, in this case, the thing that might fail, that might cause a problem is this conversion to int. You wrap it in something called a try clause. So that's just a try keyword with a colon after it, and then the stuff that might fail you should indent. And at the end of that clause, you put an except statement, and in that except clause, you say what kind of error you're expecting to happen here. So here, I think that I might get a value error. So in this case, there's a few ways we could handle this. So this means the user typed in an input that was not valid. So depending on exactly how you wanted this game to work, you could treat that as a bad guess, or you could let them input something else again. So if you wanted to treat it as a bad guess, you could say something like, so here's the mean thing to do to the user. Tell them that they made an invalid input, and I'll just assume you meant -1, which is a completely useless guess. Doesn't tell you anything about the information or about the value of this thing. Of course, that's too low, always. So let's try this. I'm going to guess P. Nope, your guess is too low because it's assuming now that I meant -1. So a little bit nicer than the program crashing and kicking you out, but not such a great way to do it. Other options might be to let them enter their guess again. So if you wanted to implement that, maybe the tidiest thing would be to define a separate function for reading an integer that would look like this. Let's do it this way. So we'll use this try except. Okay, so we define this separate function called readInt that tries to read an int and returns its value using the prompt that's specified. If that fails, it returns this special value called none. And now we'll try and be nice to the user and say something like, if guess equals none, or even better, while the guess equals none. So as long as this readInt returns none, we'll print something like invalid input, try again. And we won't even print that, we'll just okay, so this little block of code here will say try and guess the number. You'll enter something. If you enter something wrong, it's going to come back as none, and in which case it will tell you that was an invalid input and try again. See if that works. And it doesn't punish the user for doing that. Where did I get this? Okay, so if I put in U as my guess, it tells me invalid input. Whoops. Try and guess it. So let's try and guess 45. That's okay. Let's try and guess www. That's an invalid input. Try again. TTT. Still 9 guesses left. And it'll keep pestering us this way until indeed we enter a valid input. And then we get it wrong and continue. Okay. So this is now a game that, and entering blank works as well. So now this is a game that's robust to bad user input this way. It'll keep pestering them to enter a valid input. Okay. So you could still polish this thing definitely a lot more. Things that would be nice but are a little bit difficult to do with text games, or maybe to put a timer on the guesses to only allow a certain amount of time. Otherwise, you can also fire up a calculator and figure out what the optimal guess should be. But that's the kinds of things that you might do to polish this up. But again, once you know the strategy and once you can do, if you can add 2 numbers and divide by 2, then you can win this game all the time. So it's not a super exciting game. Let's try and make a better game. So let's go for a game that is more of a spelling game or a word scramble kind of game. So here what I would like to do is, we'll add some features later, but the basic thing is the computer picks a word from the dictionary, scrambles its letters, and then shows them to you with the letters scrambled, and then you're supposed to make a word out of those letters. Now you have to be a little bit careful here because sometimes with a particular bunch of letters you can make more than one word, and the word that you make may not be the word that the computer picked. That should still be okay. So for example, you know that if you see AET, if the computer gives you those letters, well, what's a word that you can make with that? T. Any other word? Eight. Eat. So lots of words that you can make out of that, and somehow, why should you have to figure out which one the computer is thinking of? So we'll have to deal with that issue that maybe the word that you make is not the one that the computer thought of, but that's okay. Okay.
Where do you get all your words from?
Well, most computers have a dictionary on them somewhere. I'll just copy mine over from user share dict. So that's this big file of words. There are one per line. There's 99,171 of them. And what we would like to do is open that file and load up all the words into an array. And we've seen how to do this before. Looks like this. So you use the open command specifying a file name. You read that file, and so that gives you a big long string that contains everything in the file. And strings have this function called split lines, which will give you an array with one line per item. That'll give us this list of words. Okay. So let's just check that out. So 99,171 words. We can look at the first 10 of them. And we already see some problems with this list. There's a bunch of words that have apostrophes in them. And I don't know, do we want those? No, probably not, eh? Okay, so let's get rid of the words that have apostrophes in them. So we'll say words is equal to every word W that's in words, but only if apostrophe is not in W. Let's see if that works for us. In fact, we can test it. Oops. So now if we look at the first 10 elements of words, we got rid of all these apostrophes. Any other things we might want to trim out of there? I'm not so keen on these things that start with capital letters, because they could be acronyms or they could be names of places or something, and they're a little bit iffy too. Sometimes we don't, in some games you don't consider those things words. What we want is something more like what you find in the middle of this list. Like if I look at 600 to 610, well, no, you're still seeing capitals. 6,000 to 6,010. Actually, even then, you're still seeing a lot of capitals and names. Don't like those so much, so let's try and get those out of there. So, see how to do that. Python string is capital. So we look at the common string operations.
We'd always check the first letter of the word is the same as the word below it.
Yeah, I guess that's what we'll have to do. There doesn't seem to be an easy way to do it. And so we can say, from this list of words that we've made so far, is we'll keep only the ones whose first letter, that's W at 0, is equal to W at 0 dot lower. So only if they're lowercase, if the first letter is a lowercase letter. Try that. Look at the first 10 words we get that way. Now we're getting somewhere. We have real words here. See any other ones we should toss away? Yeah.
Single letters.
Single letters seem kind of boring. Probably 2 letters as well. So let's scan this thing once more. And only if the length of the word is bigger than 2. Now we're getting some interesting words. So reasonable collection. If we pick one of these, maybe we'll have a good chance. Okay. All right. So now we have this good list of words to work with. What's the next task that we need to perform to get our program to do what it's supposed to do? We need to pick a word, and again, it's not going to be much fun if it picks the same word every single time, so we needed to make a choice that's different each time, and again, the place to look for that kind of thing is in the random module. So one thing I'll tell you right now is very often in my course evaluations, I get the comment that says, "Oh, this guy doesn't know how to do anything. He's always looking things up on Google." That's not true. I've written this program before. I know what to use. But what I want you guys to know is when you have a question like this, how to look it up. So in this case, I know which method to use from the random module, and I know it's in the random module. But I want you guys to be able to know, to be able to do these things yourself as well, so that I don't give you an assignment question and you say, "Oh, he never showed us this thing that was in the Python language that we could have used for this question." You can use anything that's in the language, just Google it. And so if we look at choice, there's a thing called random.choice that takes a sequence. A sequence can be a list, and so it says it returns a random element from the non-empty sequence. So that's what we have. We have a list of words, and we want a random one, so we'll pick one from there. So now we'll say X, that's the word that the program wants, is a choice from words. And since we're using that choice function from the random module, from random import choice. So now it picks a random word. And we can see that this is working by running it a bunch of times. It picked reunion, it picked nods, it picked locksmith. So indeed, it's picking different words all the time. Are they random? I don't know, but they're different all the time. It's good enough for us. All right. Now we want to scramble these letters. Yep.
Do you know how to find the dictionary on a certain user?
How to do what?
Find the dictionary that you're using?
Depends on your operating system usually. Most OSs have one lying around somewhere. If you just want one, once I get back and I make this, this file readable, you can just grab it out of this directory. You can grab this dictionary if you want. Okay, so now we want to show this word to the user or show the letters to the user, but we want them scrambled. So how are we going to do that? Sure, we can split it. And then what are we going to do once we split it? We can then start picking out letters one at a time from the split word and showing them, using random to do that. But I think we've seen something else that will let us do this all in one shot. Yeah? Yeah. So again, let's browse the documentation a little before we build the wheel ourselves. And we'll see that there's a thing called shuffle that takes a sequence and shuffles it. So we'll take this string and turn it into a sequence of its individual letters, and then we'll shuffle that. So let's do that. So we'll want to display, or I don't know, let's call it XS for the X that has been shuffled. So first thing we want to do is take X, which is a string, and split it. And we actually want to split it on the empty string, meaning that we want to pluck out each individual character by itself. So this is sort of a complicated operation, so let's do it right in the interpreter. So let's say X equals reunion. Let's import random. And now we're going to say XS equals X dot split on the empty string. Doesn't want to split on the empty string. Okay, we'll have to do this another way. And we'll say each character for C in X. Okay, so that's another way to do it. Seems split doesn't like to split on empty strings. So we'll say C for C in X. So X is basically an array of characters, and we say, give me the list. This is a list comprehension, where the elements of that list are C for each character C that appears in X. So now it basically turns, doesn't turn X into, but gives us an array that contains these things. And now we want to use random.shuffle on XS. And now if we look at XS, indeed, the characters are rearranged. If we do that again, they're rearranged again. So we keep getting different rearrangements. Okay, so first thing we do is we turn it into that, and then we say shuffle XS. And from random, we'll import choice and shuffle. Shuffle XS, that's right. Okay. So now we have this thing that we're ready to display to the user. So let's print this thing. Well, let's wait until the user gives us a guess to see. Once the user inputs something, we'll check to see if it's right or not. But we'll still have to deal with that issue. But now let's just show it to the user. So that would be something like, make a word out of these letters. And what are these letters? That will be maybe a space dot join XS. Let's try that. Good. So we've got this thing correctly displaying the question letters to us. Now it's just our job to make a word out of these things. So let's say guess. We don't want to print it. We'll make this into a raw input. Okay, so now it's going to ask us to actually make a word out of these letters. It's not so nicely formatted. Okay, so the word is kookaburras. That's what the computer picked. We'll eventually stop printing that, but it certainly helps us for this one because I would not have guessed that from the scrambled version. So now the user is going to type in a word, some guess. I don't know. And something's supposed to happen. So what should we do now? What's that? Check if it's right. So checking if it's right, the sort of cheap way to do it is just to see if the user made the same word that we guessed. So we could say something, if guess equals X, that was our original choice, correct. You're right. So that's the cheap way of doing it. So we can try, nope, says you're wrong. So let's try severer. Correct, you're right. Good, that seems to work the cheap way, but it's still going to run into some problems. There's a good one. And that, let's to see what kind of problems we run into, let's look at some short words. Whiz. Oops. And let's... So is there another word here we could make other than wed? Yep. Do. And it says, no, you're wrong. So that's not what we want. We want some more clever way of checking to see not only if this guess is the word that, that we picked, but if it's actually any word, that's okay. Yeah? Okay, so what we could do, instead of saying if guess equals X, we could say, is guess in our list of words? Now, Is that enough? So, well, let's see. Cow. Yeah, that's right. Not quite, eh? So this checks to see that we indeed wrote a word that's in the list, but it's not using the letters that it's supposed to use. So we somehow need a way to check both these conditions. The guess has to use all the letters that we gave, that we provided, exactly the right number of times for each letter, and it also should be in the dictionary. So we know how to check if it's in the dictionary. That's this if guess, or guess in words. But we also need to know if it used all the same letters and all the right numbers of times. How do we do that? What's that? An additional clause, but what is that clause going to check in the if statement? Well, guess is a string, and x is another string, so we can't say guess in x. So the thing is, maybe we'd say guess in x and guess in words. In one string, in another string asks if it occurs as a substring. So for example, hi is in Ohio. It should be in Python when I do that. Is hi in Ohio? The answer is yes. But that's not quite what we want here, right? Because it won't be that it's in there, it's that it's some permutation of the same letters. Yeah?
Check if each letter is in there, and then remove that letter from the array.
So we could go through this thing, checking the first letter of the guess, making sure that it's in the array, and then removing that from the array, and then the second letter of x, seeing if that's in the array, and then removing that from the array, then the third one, and so on. That would work. You think of another way of doing it?
If you make both into a list of characters and then sort them, and then compare it if they're equal.
Yeah. So what we would like, maybe, is, so what we really want to know is if one string of characters is a rearrangement of another string of characters, right? We want to know if guess is just a reordering of the characters in X. So those are called anagrams, right? Reordering of these things. So let's write a function called isAnagram, and it'll take, word 1 and word 2 as arguments. And let's see what we can do. So let's say word 1 is equal to eat, word 2 is equal to 8. Now, one thing you can do to make word 1 and word 2 be the same in some sense is to sort their characters alphabetically. So let's see if we can get that. So what happens if I ask for sorted of word 1? I get the array that contains A, E, T. Right? Those are the letters in word 1 sorted. And if I ask for sorted of word 2, well, I get the array that's A, E, T as well, because it's the same letters, just in a different order. But if I sort them alphabetically, I'll get the same array. So actually, the simplest way to test if one word is an anagram of another is to sort them both. Sort both their sequences of characters, and then just ask if those things are equal. So let's say so that says that that's true, and let's make sure that there's nothing weird happening. Let's do cow and cod, and that's false because cow sorts actually as COW, and cod sorts as CDO, so those two arrays are not the same. So the isAnagram function is pretty easy. We just ask if the sorted version of W1 is equal to the sorted version of W2. So now we say if guess, if is anagram, guess, and x. And so if it's an anagram, meaning we used all the right letters, the right numbers of times, and the guess is actually a real word in the dictionary, then it's golden. We can use it. So let's try that. Okay, so the computer guessed Meg. It took a random permutation of those letters, and that permutation happened to be Meg. That happens sometimes. Is there another word we could make? Gem. Correct. So it indeed went into the dictionary and found gem. But let's try the other case where we do it wrong. So let's try cow. No, you're wrong. So now we've got the main, the sort of main logic of this program. Now all that's left is just to add some bells and whistles to turn this into maybe a compelling game. Let's see. Let's play it for a bit and see if it has any issues. So one thing I keep doing here is adding one last restriction on the length of the words to be, in this case, 4, just to see if the game is playable that way. We won't print the word that the computer guessed. Okay, so what's that? Sirs. Correct. Okay. The one-shot game is maybe not so interesting. So maybe we want a while loop. All right, so let's put a while loop around this thing. We want some condition here. So how long should we play? Until you put 99? What do games have that make them a little more compelling? Like scores, right? Scores, lives. Maybe you don't get to play this forever. So maybe we want to say something like, you have 3 lives. And every time you guess wrong, the number of lives decreases. And so now this will continue as long as the number of lives is bigger than 0. And once it's no longer bigger than 0, you get a game over. All right. Lice. This one? I would say odes. Already for 4-letter words, it's surprisingly difficult. Good. So let's get something wrong. Let's say the letters are right, but they're just not a word, probably. Nope, you're wrong. 2 lives remaining. I don't know, is this a pirate dictionary? No. Of course. I don't know, what's this one? What? Ween. Punt. All right, and let's. Okay, so it has a number of these. You get some number of guesses. What else might you want to add to this? Well, you might want to keep a counter of how many you got correct. And then at the end, you can say what their score was. So this will then, at least at the end of this thing, tell you what your score was. Know this one? Gassy? No. Doesn't look right. Leap? Loud? Tilt? Stoop? I don't think so. Pant. Oh, there's a good one. Park. Towel. Bigger. Good. So it tells you your score with a typo. And now, add whatever you want to this. This restricts you right now to 4-letter words. Luckily, we didn't run across any that were too bad. But, as your score increases, maybe once you get 10 of those, you could jump up to 5-letter words. And once you get 10 of those, 6-letter words, and so on. So the game would actually get harder as time goes on. And you can see that it actually doesn't take long to make a game that is fun to play this way. Okay, so that's a good place to leave it for today.